welcome back. This is another video lecture series on deep learning. This is Dr. Chiranjeevi Manike, Professor in Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. So this is an introduction session on this deep learning. So I would like to give a brief idea. Mainly, I would like to elaborate the definition of machine learning. Mainly, what is learning and what is the correlation between the deep learning, machine learning and artificial intelligence. I would also present few examples to understand much about the difference between the deep learning, machine learning and artificial intelligence. So first let us try to understand what do you mean by traditional programming and machine learning. So machine learning, if you Google it for the definition of machine learning, we'll find without explicitly programmed, right? So machines, this sentence need to be understood clearly. What do you mean by this explicitly, without explicitly programmed? So first let us look at what is a traditional programming model and how the machine learning model, so that you will get little bit clarity, and then the couple of minutes you will get more clarity on what is machine learning, and then we'll see how AI, deep learning and machine learning are correlated. And if you look at this image, and in this a traditional programming model, like a classical programming, if you could take any programming languages, C, C++, Java, or any programming languages, classical programming languages, we set the rules, we define the set of rules, and we supply input data. So then the program, whatever the program, like suppose if you want to find out the given number is even or odd, and if you want to find out the sum of natural numbers, or if you want, or any complex function, if you could implement using any programming language. So the rules need to be defined, and then the data need to be supplied as an input. So this program would produce the answers. Like suppose if it is the find the sum of n natural numbers, or to find even number or odd number, or any such simple examples, anything. So it would produce the respective answers. That is how the traditional programming works. So we need to understand what is given as a input. Like here we are giving rules, set of rules. Like suppose if the problem is to find out the given number is even number or odd number, so we have to define the rules to find out the even or odd number. So next, the data, like suppose if you want to test, or if you want to make use of this application program, then we supply the data to find out. Like suppose if it is that there is a large number, though it is large, it can be easily identified. So that need to be supplied as a data, and what it is producing, answers. Like even number, odd number, it will produce either answer is a even number or odd number. And if you look at the machine learning perspective, and what is being given and what it will produce. So here you can see the data also given as an input to the machine learning, and answers, and this is different from the rules. Okay, answers are given as input, and then it find out the rules. Like suppose, let us take one simple example to understand in detail. Let us take marks and grades. Marks and grades. Suppose if you supply, let us say some 10 marks grade A, so 8 marks grade B, so 10 marks grade A, so 7 marks grade C, 8 marks grade B. Like if you supply this kind of data, that means if any student got 10 marks, then he would get grade A, 8 marks grade B, and 10 marks grade A, like this. So if you could give this kind of data, so then the machine learning will generate the rules. Machine learning generates the rules. That means, so grade A, how the grade A been assigned. So how many marks need to be secured to acquire the grade A? How many marks need to be secured to acquire grade B? So like this kind of correlation will be identified. So if marks more than are equal to or greater than or equal to 10, so if marks greater than or equal to 10, then grade A. If marks less than and greater than or equal to 8, grade B. And if marks less than 8 and greater than or equal to 7, grade C, like this. So this kind of rules will be identified from this given. This is input data, and this is the input data. So, and these are the answers. So that if you supply any data, so once machine learns, so then that model can be used. Like suppose you have some like a data, so 9.5 marks. If a student secured 9.5 marks, so then we can, with the help of this machine learning, so we'll get that, we'll assign the grade. So that is the major difference between a traditional programming versus machine learning. And let us take another a little bit a complicated example, that is to understand how machines learn. So as I said very beginning, a sentence or a part of this definition you will find without explicitly programmed. So without explicitly programmed, like means, like suppose if you have a machine, so machine means it could be any hardware, like it like suppose if it is a computer, anything, any hardware machine, how it learns without explicitly programmed. So without operating system, this machine will not work. Without supplying data, input data, this machine will not process any data. Like, so there is no such, that means what my objective is. So what do you mean by this without explicitly programmed? So that need to be understood. So I'm attempting to explain this with the help of this regression, how a machine will learns. So let us just compare with how as a human being, let us take one simple example. Like in most of the schools we teach like pre-primary children's nursery, how we teach very beginning, how we teach them, even how as a human being, how we learn, how a particular bird or a particular animal would learn. So that concept need to be understood so that we can correlate with the machine learning. So then machines, like without explicitly programmed, so machines will not learn anything on their own. So that need to be clear. So here, if a machine learning means, so we have to write program, so that the program, like suppose if you write a program, and the program will need an input, and we have to define the set of rules and also the answers. So all this information is required. So based on that, it will learn. And if you go in detail, so like suppose as I said, and if you want to teach a child to recognize an image like a cat or a rat or a dog, how we teach this and how a child learn from this. Okay, this, so here what we are teaching, so we are teaching, that is like by showing some images, cat or rat or any animal images, and we'll say this is cat, and by, so this is a rat and this is dog, like this. So the children will try to identify to memorize whatever they have seen. Like how, like suppose if you are shown the dog image, so they will try to identify the features, and they will try to remember how the dog looked like. So like suppose if you give very limited knowledge means if you are shown only like let us say 5 animals, so each animal one image you have shown, in that case for the child it will be very difficult. So that is depends on the maturity level, it will be very difficult. So if you show more images, like suppose if you are shown so 10 images of cat and 10 images of rat and images of dog, like that, so the child will learn more and they would remember many things, and in terms of the features how a particular dog or a cat or a rat would look like. So that that is the process of learning. So we have to supply the knowledge, so then from that they will understand, so what is like how the dog look like, how the cat look like, that. So they will store that knowledge, so that whenever we show some other images to test whether he could able to recognize that, so then he would recall whatever the knowledge he obtained. So based on that he would able to recognize that image. So, and coming back to the machines without explicitly programmed, so in this case how we can teach the machines. So we discussed how we teach like students or children or anything. So we have to understand how do we teach the machines, that is to learn. So we teach the machines by giving the data. Like suppose if you go back to the previous example, here we teach the machine by supplying the data like marks 10 and grade is at 7, 8 grade B, 10 grade A, 7 grade C, like this. So these are very limited, right? These 5 tuples are very limited, but in the real world we supply huge amount of data. That means many samples would be supplied as input, so that like suppose from this, like suppose if you have submitted or supplied this very limited amount of data, so it will understand very little, and like suppose if the students secured 9.5, then machine will not understand which grade need to be assigned, because there is no such information in this data. Okay, like suppose if a student secured 10 marks, then machine would able to assign the grade A, because the relevant example, the knowledge already given to this model. So that is the way. So we have to supply all instances. Like suppose if you want teach how to identify a dog, so you have to supply all the dog images in different angles, right? Different colors, different varieties, all if you would supply, and they would easily recognize it. So the more information you give, the more accurately they would able to, or the model would able to predict. So in this case we are supplying the data as a knowledge. That is the way we are teaching. So then the models, that means we have to write a program that is to identify the correlation between the given data. So like in the previous example, it has to identify the correlation between the marks and grade, so that it can come up with a rules, a set of rules, so if you supply any new data, like suppose if a student secured 10 marks or 9.5 marks, then it will, based on the rules, so it would identify which grade need to be assigned. So that is the way machines will understand, learn. So let us just go a little bit deeper, that is to understand how the machines, that is by with the example of a regression. And this image, this is a regression equation, and the values, what is y and what is this theta 1 and what is theta 1, theta 2 and the x. These are all you can understand from this here. And this is a regression line, is a straight line. We are not going to discuss in detail about this, but how regression line, because we have already studied like a line equation, that is y is equal to mx plus c. So that is to identify the relationship between the dependent and the independent variable, and this is a dependent variable and these are the independent, x is an independent variable. So, and this is a y-intercept. So how this, like in machine learning, how like a regression problem, how a machine learning regression works, how it learns. So that I'm just attempting to explain in detail. So here the y-intercept is for 0 value of x and what is the value of y, that is you can find out here, intercept theta 1. And here and you can find out the x, that is a independent variable and y is a dependent variable. Y is a dependent variable and here the theta is a slope. Next there is an error, that is because here we have to predict, like the previous example, we have to predict the grade. So sometimes if suppose if there is no enough, like the system is not 100% accurate, okay, so in that case 100% not accurate, like suppose there is an error, percentage of error, so there would be some random error possible. So that is, and we are going to predict a value and this is a observed value. Observed means it is an actual value and this is the point represents a value which is predicted. Value which is predicted. So that means there is a difference between the predicted value and the actual value. So that is a error. So in this case, how this regression model, that is if how the machine learning model learns. So the machine learning model in the regression case, it has to construct the straight lines like this, and this is one perfect straight line where the error is very little or very minimum, so minimized or optimized we would say. Like suppose if you take one line, straight line, in this case, like suppose this is one observed value, and this point would be the predicted value. So still there is a difference, okay. So like for every observation value, there are set of all observation values, all these dots represents the observed values, actual values, and we constructed a straight line, regression line, that is to express the correlation between these two, that is x and y. So and suppose if you construct this a straight line, regression line, then we'll find out all the errors and we'll sum up. So the total error that need to be minimized to find out the exact correlation between the dependent and independent variable. So this, like suppose if I construct like this, then we'll find out, we calculate the we calculate the total error. So that need to be minimized. So next again, so suppose if I try to draw a straight line, then the error would obviously minimize because it is little bit moving close to this straight line, okay. Or the differences between the actual values and predicted values, if you sum all these values and this value should be minimum. So wherever we get this very minimal value, and that for any like a regression line, and that would be considered as a best fit or best that is the best, it can express the correlation between the dependent and independent variables. So that is a way the regression. So this is, that means we have given a data, like we'll give all the y values and x values. So it will try to identify the correlationship between the x and y values. Like suppose here only one independent variable is here present, but in the real world there will be many independent variables. If you take a house price prediction, there will be independent variables like number of bedrooms, and what is the plot size, what is the carpet area, and what are the nearby locations, is there any school facilities, uh, like location. There will be many number of factors which influence the price of a house. So all these factors would be considered as a independent variables. So here the dependent variable is a house price. So this house price would be influenced by the all independent variables. So this error need to be minimized. The dependence this in terms of this equation, the error need to be minimized. So once it is done, then the model is ready. Model is nothing but mathematical equation. Like suppose y is equal to, let us say, suppose there are two independent variables, x1, x2. So like I would express like this. So some 0.5 times x1 plus 2.6 times x2 plus y-intercept, I directly write it. Okay. So in this case, and this is the final regression equation, that is by constructing many straight lines like this and identifying the total error, and for this the error rate is very minimum. So that would be considered as a best fit. So that means, so that is a way, that means here without programming this machine alone, it cannot come up with this equation. So we have to write a programs so that that is to find out a predict a value, that is to draw the straight line, or not drawing that straight line, if what would be the predicted value and what is the actual value and what is the difference, and how, and to find out the sum of all the errors and where it is minimized. So for the next iteration, suppose if it is becoming more, and then we have to come back and move in the other direction. So that is the way we'll minimize. So then that would be considered as a best fit. So that is how a machine learns. In this case, without any program or without anything input or without this data, that means, so huge information need to be submitted, that is in terms of like all y values and all x1 x and x2 values. All this information need to be supplied so that it will try to identify as much as more accurately the correlationship between the dependent and independent variables. So then the model is ready, so then we can test it. So whether it is that is by taking another new instance, we can test it whether it is performing well or not. So that is the way machines. So that is the clarity you need to have, like what do you mean by this without explicitly programmed. So the more data you supply, so that we will discuss in the coming lectures. So let us quickly understand the difference between the deep learning, machine learning and artificial intelligence. These are all interlinked. So let us see what is artificial intelligence. So this is as per the definition. So it is a branch of computer science. It's computer science. So that focuses on developing the machines software. That is, machines means hardware and the software which are capable of simulating the human intelligence. Like suppose the chatbots. There are many other applications that will be discussed in the coming sessions. So what are the intelligence, the process we could mimic with the help of artificial intelligence, like learning, how the humans learn, so that can be mimicked with the artificial intelligence, and the reasoning, problem solving, perception, how the patterns would be recognized by seeing images, videos, audios, etc., and decision making. So it is a superset, and machine learning is a subset of artificial intelligence. So far we discussed, I think I have an example. In coming lectures, we'll discuss many examples so that you'll get much clarity on that also. So machine learning is a subset of artificial intelligence that enables the computers to learn from the data. Without data, the machines will not. So without program also, programs, that is to find out, extract the rules, or to come up to build a model. Model means nothing but a mathematical equation. So it's a subset of artificial intelligence that enables the computers to learn from data, improve their performance on a task, like regression equation. So it has to find out the correlation, then find out the error. So then again that need to be improved. That means error need to be minimized. Improving the performance means error need to be minimized. That means whatever the value predicted, that must be very close to the actual value. So that is by supplying more data or more all varieties of the data, so that it will understand the correlation, so that it could be able to predict the values more accurately. So here you can see here, without being explicitly programmed. So that does not means without program the machine will understand. So that is the clarity I would like to give, that I attempted. I think you are all clear. Next, deep learning is a subset of machine learning. So that uses artificial neural networks, that is inspired by how the neurons fires in our brain. And like, suppose if you watch a video and if you listen a voice, so like how our brain neurons in our brain fires, how the electrical signals being transmitted from one place to another place, how a particular neurons get fired. And so that based on that, so they develop the artificial neural networks. So the deep learning is based on the artificial neural networks, so that automatically learns patterns from the data. Automatically in the sense there is nothing. Again, we have to program it, so to learn from the data. So let us quickly go through the two examples, so to understand how these three fields are interrelated. So let us take one simple example of online shopping. Here the AI, a chatbot that is helps answer the customer questions on an e-commerce website. And in this case, the machine learning, so the website recommendation product based on a browsing and purchase history. Like suppose if you open any e-commerce website, and if you browse a product, and then you would get the recommendations. So that is with the help of a machine learning, the recommendations would be given. Next, the deep learning in this application plays important role. That is, the recommendation system uses, as I said, the machine learning. You can also use machine learning to build the recommendation system, but how? And again, we'll come to the again we'll take one more example to understand what is exactly the difference. Suppose, because the deep learning is a subset of machine learning, so what kind of problems could be solved with a deep learning, what are not solved with a deep learning, that we will discuss it in the coming lecture. So the recommendation system uses a deep learning to analyze user behavior and suggest highly personalized products. So next, one more example, like a fruit recognition. This is very simple example to understand. Here the AI, that is rule based system that identifies fruit by checking its color and the shape. So machine learning in this case, the system learns to recognize the fruits by analyzing the multiple labeled images, like many apples, many bananas, etc. With all labels we would supply, so that the machine learns, like how we learn. Next, in this example, like a fruit recognition, the deep learning works like a deep neural network, processes the images and identifies the fruits even if they are rotated, blurry, or partially hidden. So the complex features been extracted, so that this deep learning models mainly used for the complex analysis. So I would like to emphasize this, that is, we will discuss in the coming lecture about the major difference between the machine learning and the deep learning. So that's it. This is an introduction to this deep learning. So let us quickly summarize what we have discussed in this lecture. So we mainly discussed, I try to attempt explain the concept of what do you mean by a learning. What is learning? And I explained in detail, uh, that is how, without explicitly being programmed, that is the part of definition you will find. So you need to understand that without explicitly programmed. What do you mean by that? So I give enough examples also to understand that. And then we understood the differences between the machine learning, deep learning, and artificial intelligence. So thank you for watching.